Okay, so in this next problem we're asked to plot the points and find the slope of the line passing through the pair of points. And our points are 0, 9 and 6, 0. So we're going to start by plotting the points, 0, 9, which is going to be at the center here, but up 9. So it's going to be somewhere off the graph, somewhere around here. And then our next point is 6, 0, which is going to be on this x-axis. It's going to be to the right of the origin by 6. So we're going to go 1, 2, 3, 4, 5, 6, and plot our point right there. And now what this problem is saying is that there's a line connecting these 2 points, and it wants us to know what the slope of this line is. So if you recall, the formula for the slope is y2 minus y1 over x2 minus x1. So we're going to go y2, which is 0, minus y1, which is 9, and then x2, which is 6, minus x1, which is 0. And we're going to get negative 9 sixths, which if we divide it by 3 to reduce it, we get negative 3 halves. Okay, so in this next question we are asked to plot the points and find the slope of the line passing through the pair of points. And the points we're given are negative 3, negative 2, and 1, 6. So the first thing we're going to do is we're going to graph these points on the graph. So we go to the left of the origin 3 units to get the negative 3, and then we go down 2 units to get the negative 2, and we get 1 point right about there. So that's our negative 3, negative 2 point, and then our next point is 1, 6. So we're going to go to the right of the origin by 1 and then up 6, so it's going to be a little bit off the graph, but it's going to be right about here. And then now this question is saying, imagine if we have a line going through these 2 points, a line that looks something like this. It's asking us to find the slope of the line passing through these 2 points. And if you recall from, I believe it was 1.1, the formula for the slope is y2 minus y1 over x2 minus x1. So our y2 in this case is going to be 6, and our y1 is going to be negative 2. So we're going to write 6 minus a negative 2 over x2, which is 1, minus a negative 3. And if you have a minus a negative number, it's like addition basically, so we can change this into a plus and this into a plus, and we will get essentially a rewritten thing that says 6 plus 2 over 1 plus 3. So 6 plus 2 is 8, and 1 plus 3 is 4. So our fraction is 8 over 4, which can be reduced to 2 if we divide both the numerator and the denominator by 4. So we get that our slope is 2. Okay, so in this next problem we're given the exact same question, just different points. The points this time are 5, negative 7, and 8, negative 7. So just like before, the first thing we're going to do is graph the points. So in order to get the 5, we go to the right of the origin by 5 units, so we go all the way over here, and then we go down 7, which is going to be a bit off of the graph, probably even at the edge of this page here. Right about there is where I'm looking at. And then our next set of points are 8 and 8, negative 7. So we're going to go to the right of the origin by 8. So we're going to go 1, 2, 3, 4, 5, 6, 7, 8, and down. Right about there. And then it's saying if we have a line, which imagine it being a perfectly straight line, but if we have a line going through these 2 points, what is the slope? So we go over here to our slope formula, and we fill in these variables with their correct numbers. So we're going to have negative 7 minus a negative 7, and then we're going to have 8 minus, what was it, 5? Yeah, 8 minus 5. So a negative being done, or subtraction being done to a negative is the same thing as addition. So we have negative 7 plus 7, and 8 minus 5. Negative 7 plus 7 is 0, and 8 minus 5 is 3. And when we have a numerator of 0 in a fraction, that is just the same thing as 0. But if we have a numerator in the denominator, then that's undefined. And that makes sense. There is no slope here. There's no change in the line. It's perfectly horizontal. So it makes sense that the slope would be 0. Okay, so in this next question we're asked to plot the points and find the slope of the line passing through the pair of points. And the points we're given are -6, -1, and -6, 4. So the first thing I'm going to do is I'm going to start out by graphing these points. So the first point for -6, -1, we're going to go over 6, so 3, 4, 5, 6, and down 1. And then for our next point, -6, 4, we're going to go to the exact same spot on the x-axis, just up 4. So we're going to go 1, 2, 3, 4. And then we're going to draw a line connecting the two. And imagine this is a straight line. And now we have to find the slope of the line connecting these 2 points. So in order to do that, we're going to use our slope formula, y2 minus y1 over x2 minus x1. Well, our y2 is 4 and our y1 is -1, so we're going to do 4 minus a -1 over -6 minus a -6. Now, if you're subtracting to a negative number, 4 minus a -1, -6 minus a -6, it's essentially the same thing as addition. So we can write this as 4 plus 1, and this is -6 plus +6. 4 plus 1 is 5, and -6 plus 6 is 0. And if you recall, any fraction that has 0 in the denominator is undefined. So the slope of the line connecting the 2 points is undefined, which makes sense because it's a straight up and down vertical line. There's no change in the rise or the run, so it's undefined. So in this next question, we're asked the exact same thing, just with different points. So now that you saw how to do the last one, I want you to pause the video, try this on your own, and come back to this when you're done. So assuming that you've tried this, let's see how you did. So the points we're given this time are 11 halves, -4 thirds, and -3 halves, -1 thirds. So we're going to start by graphing the points. Now, if ever you're told to graph a fraction, and you don't know what that fraction is as a decimal number, what you can do is, for example, with 11 halves, what I can say is that for each peg along this x-axis, this is 2 halves. For example, this peg here is 2 halves, this peg here is 4 halves, which if you reduce that is 2, and so on and so forth. So I can say this is 2 halves, 4 halves, 6 halves, 8 halves, 10 halves, and then in between here will be 11 halves. And then when we go to -4 thirds, well, this first peg is -3 thirds, and just underneath that should be -4 thirds. And then now we have our next point, -3 halves, comma -1 third. So once again, this is -2 halves, this is -3 halves right in between them, right in between the first and the second pegs. And then we're going to go down another third, right about there, and then draw a line connecting the two. And hopefully your line looks better than mine. And then we go to find the slope. So we're just going to plug the numbers into the formula. So our y2 is -1 third. -1 third minus y1, which is -4 thirds. And we're going to make our fraction. And then x2, which is -3 halves, minus x1, which is -11 halves. So once again, minus a negative is the same thing as addition. So negative 1/3 plus 4/3 is 3/3. So we have 3/3 over, and negative 3/2 minus 11/2 is negative 14/2. And now each of these fractions can be reduced. 3 over 3 is equivalent to 1, and negative 14/2 is equivalent to negative 7. So our slope is negative 1 over 7. Okay, so we're in this next problem, we're given the same question, just different points. This time our points are 4.8, 3.1, and negative 5.2, 1.6. So just like before, we're just going to graph the 2 points first. So 4.8, 3.1. I'm going to go to the right, and I'm going to almost go to 5, but then just go back a little bit because it's 4.8. And then I'm going to go up to 3 and just go just past that. So somewhere right there is where I'd say. And then negative 5.2, so we're going to go 1, 2, 3, 4, 5, and slightly a little bit more back, and then 1.6. So just over halfway between the 1 and 2 peg on this y-axis. And then we're going to draw a straight line through these points, and then we're going to find the slope. So that's y2 minus y1, so 1.6 minus 3.8, 3.1, sorry. 1.6 minus 3.1 over negative 5.2 minus 4.8. So 1.6 minus 3.1 is negative 1.5. So we're going to have negative 1.5, hold on, over, and then we have negative 5.2 minus 4.8, which is negative 10. Let me draw that 0 better. So these negative symbols are going to end up canceling out, because if you recall, a negative times a negative is a positive, and a negative divided by a negative is positive. And so when we divide these two, we get the slope is positive 0.15. Okay, so in this next question, we are asked to use the point on the line and the slope m of the line to find 3 additional points which the line passes. So the point that we're given is 2, 1, and our slope is 0. So the first thing I'm going to do is I'm going to plot the point at 2, 1 right about here. And now if you remember, a slope of 0 means it's a horizontal line. So any point along this line could work. We could pick this point, which is 1, 0. So, or it's 0, 1, I'm sorry. 0, 1, that's another point which lies on the line. Another point is this point right here, 3, 1. And we can say this point over here, negative 1, 1. These are all viable points, but you can have basically infinitely many points that are in the correct solution set as long as they're on this line here. You could have negative 1 million, 1, or you can have positive 1 million, 1, as long as they lie on this line. Okay, so in this next question we're asked to do the exact same thing as the previous one, but now we're given a different point. Our point this time is 5, negative 6, and our slope is 1. So once again, I'm going to start out by graphing the point. So I'm going to go to 5, and I'm going to go to negative 6, which is going to be just a bit off of the graph here. And I'm going to plot it like that, 5, negative 6. So the slope is positive 1, which means for every one increase in the y value, there's one increase in the x value as well. So we go up 1 and over 1, for example. And then so that point would be 7 comma negative 5. Or 6 comma negative 5, I'm sorry. 6 comma negative 5. We can go up 1 and over 1 again. And we get 7 comma negative 4. And we can do the same thing again. It's the same pattern. We're going up 1 over 1. And we get 8 comma negative 3. And this line doesn't look straight at all, but just imagine it is, and these are part of the solution set. So in this question, it's in this problem, it's the exact same question, but now our point is negative 8 comma 1, and our slope is undefined. So I'm going to go to 1, 2, 3, 4, 5, 6, 7, 8 left of the origin to get to negative 8, and I'm going to go up 1, so right about there. And the slope is undefined, so remember that if the slope is undefined, that means that the line is vertical, straight up and down. So if I'm trying to get three numbers that are part of the solution set, I can go up here, I can go to negative 8 comma 2, I can go down 1, I can go to negative 8 comma 0, and I can even go up 1 from this point. I can go to negative 8 comma 3, and these are all valid answers. Okay, so in this next question we are asked the exact same thing, just a different point, negative 5 comma 4, and a different slope, which is 2. Meaning that for every 2 increase in the y value, we get 1 increase in the x, because our slope is the ratio of y over x. So if we have a ratio of 2, it means we have 2 to 1. So 2 increase in the y, 1 increase in the x. Alternatively, we can go 2 down in the y and 1 decrease in the x. And that's the same thing. So what I'm going to do is I'm going to graph the point, negative 5 comma 4, so negative 1, negative 2, negative 3, negative 4, negative 5, and I'm going to go up to 4, and that's where my point is going to be. And because if I go to the right, I will end up going off the graph, I'm going to go to the left, so I'm going to go down 2 and to the left 1. So that brings me to negative 6 comma 2. And then if I do that again, if I go 1, 2, and over 1, then I'm at negative 7, 0. And if I do that again, I will be at negative 8, comma negative 2. Because I'll be going down 2 and over 1. So those are 3 points that you could have used in your answer. Okay, so in this next question, we're being asked the exact same thing, but our point this time is 7 comma negative 2, and our slope is 1/2. So in the previous problem, I said that the slope is the ratio of the y to the x, and so if we have 1/2, it means for every 1 increase in the y, we get a 2 increase in the x. So 1 increase in the y and 2 in the x. Alternatively, we can get a 1 decrease in the y and a 2 decrease in the x. So let's graph the point. We're going to go to 3, 4, 5, 6, 7, and then down to negative 2, right about there. And then we're going to go up 1 over 2. So we get the point 9 comma negative 1. And then we're going to go down 1 and to the left 2. So now we can go down 1 and over 2 to right about there. And then that puts us at 5 comma negative 3. And then we're going to go down 1 and over 2 again. And that puts us at 3, negative 4. And these are 3 possible answers you could have put down. Okay, so in this next question we are asked to find the slope-intercept form of the equation of the line that passes through the given point and has the indicated slope m, and then sketch the line. And the point we're given is 0, negative 2, and the slope we're given is m equals 3. So what I want to point out first is that the y-intercept of a linear equation is y, or the y-intercept will be at 0, b. And b can be any number, any real number. Now if we look here, we see that we have a 0, b. Our b is negative 2, meaning our y-intercept is negative 2. So this is kind of a straightforward equation because we have the slope-intercept form of the equation is y equals mx plus b, and we have our m, and now we have our b. So we just rewrite this with the m and the b filled in, and we will have our slope-intercept form of the equation. So we're going to write y equals 3x minus 2, just like that. And then we're going to go to graph it. So our y-intercept is at 0, negative 2 down here, and our slope is at 3, so we're going to go up 1 and over 3. Up 1, or up 3 over 1, that's what I meant. Up 3 over 1, like that. And then we go down 3, left 1. And then we can try to sketch a straight line, but I don't know how straight it will turn out, not very. I will try to do it better, but just imagine this as a straight line. So, yep, that's how you do that one. Alright, so in this next question we are asked the exact same thing, but our point now is negative 3, 6, and our slope is negative 2. So I'm just going to write the slope-intercept form of an equation with everything as variables so we know what we're looking for. So we can see here from this information we're given an x, we're given a y, and we're even given a b. The only thing we need to find is m. So in order to do that, we can just plug all these things into their respective variable and solve for b, I mean, not, this is our m, we're given m, so we need to solve for b. So we're going to plug in 6 for y, we're going to plug in negative 2 for m, we're going to plug in negative 3 for x, and we're just going to write plus b, and we're going to solve for b. So negative 2 times negative 3 is positive 6, so we have 6 equals 6 plus b, and because we're solving for b we have to subtract 6 to get b alone, and we get b equals 0. So now we have our b, we have our m, and we can write the slope-intercept form of the equation, which is y equals negative 2x plus 0, because b is 0, but you don't have to write it if it's just plus 0. So now when we go to graph this, our y-intercept is going to be at 0, 0, because that's our b, 0, b, and b is 0. And then we're going to go down 2, right 1, down 2, run right 1, and then we're going to go up 2, left 1, and up 2, left 1. And then we can attempt to sketch a straight line on the first try, but we won't do that. So, yep, just imagine that as being a straight line. Okay, so for this next question we're asked the exact same thing, we're just given different points and a slope. Our point is 4, 0, and our slope is negative 1/3. So we're going to do the exact same thing as the problem before. Y equals mx plus b. And once again, we're going to plug in all the numbers to their respective variables and solve for b. So we're going to have 0 equals negative 1/3 times 4. And I like to write the whole fraction when I'm multiplying fractions. So negative 1/3 times 4 over 1 plus b. So negative 1 times, or I suppose negative 1/3 times 4 is just negative 4/3. So we have 0 equals negative 4/3 plus b. And again, because we're trying to solve for b, we have to get it alone, so we're going to add 4/3 to both sides. And we get b is equal to 4/3. So then when we go to write the slope-intercept form of the equation, we have our slope and our b. So we're going to write y equals negative 1/3 x plus 4/3. And then when we go to graph this, our y-intercept is going to be at 0, 4/3, which is the same thing as 1 and 1/3, so right about here. And our slope is negative 1/3, so we're going to go down 1 and over 3. Down 1 and over 3. Down another one and over another 3. And then we can even go the opposite direction. We can go up 1 and to the left 3. And remember, the slope is negative, so it needs to be going downwards as you move from left to right. So we're going to go up another one and left another 3. So right about here, I would say. And then up 1, and then up another 3, or left another 3, I mean. And imagine that as just going through the points. They're meant to go through the points, but I can't really draw that. Alright, so in this question, in this next problem, we're asked the exact same thing, but this time our point is 2, negative 3, and our slope is negative 1/2. So we're just going to do the same thing. Y equals mx plus b. And then plug in the different numbers to their variables. So we're going to be left with negative 3 equals negative 1/2 times 2 over 1 plus b. Now this negative 1/2 times positive 2, we can actually cross-reduce this. So that leaves us with negative 3 equals negative 1 plus b. And then we add 1 to both sides. And we get b equals negative 2. And then so when we rewrite it in slope-intercept form, we get y equals negative 1/2 x minus 2. So then when we go to graph this, our y-intercept is at 0, negative 2 down here, and our slope is negative 1/2, so we're going to go down 1 and over 2. Down 1 and over 2. Down another one and down and over another 2. And then we can go up 1 and to the left 2. Up 1 and to the left 2. Up 1 to the left 2, and so on and so forth. I'll just graph these points because I'm assuming you can do the rest. And there you go. Alright, so in this next one we are asked the exact same thing, But now our point is 6 comma negative 1, and our slope is actually undefined. So because of that, I'm actually going to start out by graphing this one first, and then we can kind of work back an equation in slope-intercept form from there. So we're going to go to 6 comma negative 1, so 1, 2, 3, 4, 5, 6, negative 1. Our point is going to be right here, and remember, if the slope is undefined, it means our line is a vertical, straight up and down. So now if you look at this, you can tell that if I pick a point for here, for example right here, this is 6 comma 3, and if I pick a point here, for example, this is going to be 6 comma 0, and if I pick a point down here even, this is going to be 6 negative 5. So the one thing that we can discern from this is that no matter which point we pick on the line, the x value is going to be 6. So that leaves us with only one option. We can only write y equals 6. We can't write y equals 6 plus b or something like that, because that would alter the equation. We can't write y equals 6x, because then it means that there's something we can plug in for x that would then alter the equation. So the only thing we can write down here is the answer is y equals 6. Okay, so in this next question we're asked the exact same thing. The point this time though is 4 comma 5 halves, and our slope is 0. So once again, I'm going to start out by graphing this first and then moving on from there. So we're going to go to 4, 1, 2, 3, 4, and 5 halves, which is right here, right about. And so remember that if the slope is 0, our line is going to be horizontal. Imagine this is just a straight horizontal line. So what that means is if I pick a point over here, that's 1 comma 5 halves. If I pick a point over here, for example, that's negative 5, if I counted correctly, negative 5 comma 5 halves. If I even pick this point over here, that's going to be 0 comma 5 halves. So just like in the last problem where we saw that each point had a 6 in the x spot, in this problem we see that each point has a 5 halves in the y spot, meaning that the only thing we can write down is y equals 5 halves.